Acceleration is the rate of change in velocity. So you can use the equation acceleration average is equal to the change in velocity divided by the change in time, or you can also say velocity final minus velocity initial divided by final time minus initial time. Either way you want to phrase that is fine. I find it easier to write change in velocity over change in time, and we're all old enough to know what that means. Acceleration has a unit of meters per second, otherwise known as meters per second squared. When your velocity final is greater than your velocity initial, that means your object is speeding up, and your acceleration is going to be measured positive. When your initial velocity is greater than your final velocity, in other words, when the object is slowing down, then your acceleration is going to be negative. And of course, if your change in velocity is equal to 0, that means that there is no acceleration, which does not mean that the object is standing still. It means the object is neither speeding up nor slowing down. It is traveling at a constant speed. Okay, so a delta V of 0 means constant speed, no change in velocity. Of course, if you have a negative velocity when you're calculating acceleration, that's going to affect whether or not your calculation comes out to be negative or positive, correct? So you need to take that into account when you are doing your calculations. And if you want to know the sort of breakdown of what sign you should use, then you can see the table on page 49 of your book, and it kind of summarizes that nicely. What I'm trying to say here is essentially, just because your acceleration comes out negative does not always mean that your object is slowing down. If your initial velocity was negative, your acceleration is going to come out negative more than likely, and that could still mean you're speeding up. Or an initial velocity of negative could mean your acceleration comes out positive when your object is in fact slowing down. So use your street smarts to look at the problem and figure out, is it speeding up or slowing down? Now, acceleration, just like velocity, can be drawn on a graph. And a lot of the lines look similar to the ones we had on our distance or our displacement time graphs, but they mean different things. For example, a line that is at a constant slope like this on a displacement time graph indicated that it was traveling at a constant speed. On an acceleration time graph, that indicates that it is in fact speeding up. Okay? A horizontal line on your displacement time graph meant that it was standing still. On here, it means it's moving at a constant speed. Okay? And then you have a deceleration, which is that downward sloping line, and then an increase in acceleration is a sloping curved line. So that would be not that the velocity is increasing there, but that the acceleration is increasing there. So the rate at which it is speeding up is also speeding up.
Could you have a decreasing acceleration?
You should be able to, in which case the line would curve the other direction. When acceleration is constant, the time interval will remain the same, but the distance that the object travels will increase. When acceleration is constant, we can derive a variety of formulas from the acceleration formula, and we're going to practice deriving them on paper because typing out all these formulas would be an actual nightmare. So grab a piece of paper and a pencil. They provide a list for you of the formulas we're going to derive on page 56, but I'm going to actually walk you through the steps of getting them.